Exercise 183, page 462, question number 3, part A. Integrate between 0 and pi the function 3 over 2 cos theta d theta. Notice when we integrate to find the area under the function in this term, the angle theta is always measured in radians, and so it's quite common for limits to be in terms of pi, but not always. If we look at the function underneath, I've sketched it. It's a cosine function, so it starts at 1, and then if we look at this particular one between 0 and pi, here is pi, and so if we look at the function between 0 and pi, we can in fact see that we've got just as much area above the curve as we have below, so it's not surprising if you look at the solution, the answer is 0. But let's have a look and see why that is, or just to show that that is the case, that the area underneath the curve is 0. But we can see why by looking at the function. So, integral between 0 and pi 3 over 2 cos theta. With respect to theta equals, again I would bring the 3 over 2 outside the integral, between 0 and pi of cos theta d theta. Well, the integral of cos is sine, so this will equal 3 over 2 sine theta between 0 and pi. Using a calculator or just thinking about what a sine wave looks like, so if I were to sketch it over here at the side, a sine wave starts at 0 and looks like this. This point here, one complete cycle, is 2 pi, so this is pi. So what's the sine of pi? 0. So putting our limits in, this will equal 3 over 2. The first term, sine of pi, minus, putting the second limit in, the sine of 0. So looking at the sketch, we can see the sine of pi is 0, but you can put it into the calculator and confirm that. And the sine of 0 is 0. So in fact, both of these terms are 0. So it turns out to be 3/2 of 0, which is 0. Part B. Integrate between 0 and the pi by 2 this time of the integral 4 cos theta, or the function 4 cos theta. If we plot the function between 0 and pi by 2, so this is the point 0, this is the point pi by 2, so we're finding this area here. So we should get a value this time for the area under the curve. So what's the integral between 0 and pi by 2 of 4 cos theta d theta? Well, again, I would bring the 4 outside. Integral between 0 and pi by 2 cos theta d theta. What's the integral of cos? Sine, so this will be sine theta between 0 and pi by 2. So again, we can put the limits in. So this equals 4 sine pi by 2 minus sine 0. Again, thinking about the curve or putting it into your calculator, what does the sine wave look like? It's worth knowing these things. That's what the sine wave looks like. This point here is pi by 2, sorry, 2 pi. So this is pi. So this point here is pi by 2, and the sine peaks at 1 and minus 1. So what's the sine of pi by 2? 1. So this equals 4 square brackets 1 minus, what's the sine of 0? Well, from the curve or from the calculator, sine of 0 is 0. So the answer turns out to be 4 times 1.